Hey everybody, welcome back. This is the second part of section 1.6 where we're dealing with some other types of equations. We had a first part in which we dealt with equations, polynomial equations that you could factor, and we also dealt with quadratic form. So we dealt with those two. This time we're going to be dealing with radical equations and also solving equations that involve an absolute value. Those are just linear equations with absolute values, but still they have a special type of process. And then I do not have a video created for doing rational exponents or modeling with these equations at this moment. Our modeling stuff will max out at the quadratic stuff that you saw in 1.5, and rational exponents are beyond the scope of this course. And so you'll see those again in pre-calculus if you go on for there. Okay, so we're going to start with radical equations. By radical equations, I mean basically square roots only. All right, so it can be done for any roots, but we're going to focus on the square roots because they have some special cases that we have to be aware of, and I want you to focus on square root equations. Okay, you occasionally will see a cube root equation, but the square root equations are the ones that are the most important and have the most diverse experience, shall we say. All right, so how you want to solve radical equations is this. You want to arrange terms so that one radical is isolated on one side. So it's possible you could have more than one radical. And if you do have more than one radical, square root, you've got to isolate one of them to one side and take everything else to the other. Okay, so isolating means get it by itself. Then raise both sides to the nth power. For us, that's the second power. Square both sides, in other words. And it's both sides. You'll see in a minute what I mean by that. It's not each piece. It's all the whole side on the left and the whole side on the right. Solve it, and then if that doesn't get rid of all the radicals, you got to go back and repeat, okay, the process until you can solve just for the variable by itself. Okay, so write those down. You can pause the video at this point to do that, but I'm going to go ahead. Okay, so we want to solve the square root of x plus 3 equals x. We want to solve this equation. So isolating the radical means we need to subtract 3 from both sides in order to get the square root all by itself. Okay, so we get square root of x plus 3 equals x minus 3. All right, and then what do? We square both sides. That's raising both sides to the proper power. In this case, it's a square root, so we do the square of both sides. Notice this is both sides, right? So it's not x squared plus 3 squared, it's x plus minus 3 all squared. And remember what that means. Over here, the square root squared is just x plus 3. The square root's gone. Over here, though, what does this mean? This means x minus 3 times x minus 3. It is not x squared minus 9. That is not it. No, 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 no. All right? That is not x squared minus 9. All right? And so if we go on past this now, we need to FOIL this out. And so we get x plus 3 equals x squared minus 3x minus another 3x plus 9. See, that's how we get this. And then subtract and set equal to 0. So if I subtract x from both sides and 3 from both sides and combine like terms, I'm kind of skipping a couple steps here, but these are steps you guys should know by now. All right, you get x squared minus 7x's plus 6. Okay, so remember when you see a squared, don't forget. So I'm going to draw a line right here. I'm going to draw this line right here to say this is the old stuff. Everything we do from the red line down, subtracting x and subtracting 3 and solving, all this stuff, and really it starts right here if you want to be picky about it. Okay. This is all stuff from like 1.5. This is old stuff. And so the reason I tell you that is not to make you feel bad if you get stuck. The reason I tell you that is so that if indeed you run into an issue, okay, you know where it is. Do I have troubles with the first couple of steps, which is the new material, or do I have trouble with the extra stuff, which is the old material? Okay, and so if you struggle from here on down, then you know that you need to go back and review 1.5 a little bit better, not worry as much about 1.6 yet. You're not ready for 1.6, okay? So anyway, this factors into x minus 6, x minus 1, and so I think we can all get here that we have two answers. But we are not finished. We are not finished yet. What do you mean we're not finished? Well, we have to check our answers. Hey, wait a minute. I thought you said that was optional. We don't have to check our answers. Well, in general, that is true, guys. You do not have to check your answers in general. But with radical equations, when you square, specifically when you raise both sides to an even power, you must check your answers. You don't have a choice because here's why. Okay, why check? Is -5 equal to 5? No. But if I square both sides, what do I get? I get 25 equals 25. So we started with things that were not equal, but we made them equal by squaring both sides. That doesn't mean that we can't square both sides. That just means you have to check yourself. We have no other way of getting rid of the square root other than to square both sides. Okay, so what was our solution? 6 and 1. We need to check 6 and check 1 in the original equation, all the way back to the original. Okay, so we're going to check 6. We plug in 6 for the x on this side and on this side. Is this true? Square root of 9 plus 3 equals 6. 3 plus 3 equals 6. Yes, it is. That's true. That's good. So that means 6 is a good answer. Check. All right. But now, what about 1? All right, let's check it out. If you plug in 1 everywhere, you get 4 plus 3 equals 1. Square root of 4 plus 3 equals 1, which says 5 equals 1? Nah, that's not true. So that's no good. So we got to throw it out. Okay, we got to throw it out. All right, so I'm not sure why that slid over like that, but basically what do we have? We've got the only solution is x equals 6. 1 is what's known as extraneous. Okay, it's extra. So we throw it out. X equals 6 is the only answer. Now, you have to show me the check. You can't just give me x equals 6 as your right answer. If I don't see a 1 somewhere tested, then you missed an answer, a possible answer. Granted, the 1 is not actually a solution, but it was a possible solution. You have to check both of them. Okay? So just like with the last video, what I want to do now is I want to give you your own problem. I want you to try this problem. I want you to take a few minutes and try it. Okay? If you need to go back and watch the last little bit again, that's fine. But at this point, I want you to pause the video, try this problem, and then I'll show you the answer when you come back. Okay? So step 1, we need to isolate. So that means we need to add 7 to both sides. Okay, that gives us 4 square root of 3x plus 2 equals 16. Still not isolated because of the 4, so we're going to divide both sides by 4. So we have 1, 3x plus 2 now equals a total of 4. And so now what do? We square both sides, both entire sides. All right, and so we get the square root of 3x plus 2 squared. We get 4 squared. And so we get 3x plus 2 equals 16. Subtract 2 from both sides. We get 3x equals 14. Divide both sides by 3. We get x equals 14 over 3. Okay? We still need to check it. So let's check it. We go back to the original equation. 3 times 14 thirds plus 2 minus 7 equals 9. Okay, so 3 times 14 thirds is just a 14 plus 2 minus 7 equals 9. Square root of 16 minus 7 equals 9. Square root of 16 is 4. 4 times 4 is 16. So 9 equals 9. And that checks. Okay, so again, your answers are not correct in this particular section. When you're solving radical equations, if I don't see the check, and this includes your quizzes online, right? You got to submit your work. If I don't see a check, then you're going to lose points for not showing all of your work. Okay, make sure you do a check. You can use your calculator to do the arithmetic, but I've at least got to see that you plugged it in and that you checked it. Okay, I don't need to see every single one of these steps, but I do need to see that you checked it for every answer, for every possible answer. Okay? All right, So the other type of equation we're going to deal with here is absolute value equations. And the reason that I group these together is because they also often give you two answers. But unlike that, you don't have to check this time. Okay, so remember that the absolute value of u equals c means that u is equal to c or u is equal to negative c. Remember how absolute value works. You either get exactly what you had or you get the opposite of what you had. Okay, and so if we work through this example, absolute value of 2x minus 1 equals 5, you isolate the 2x minus 1, it's already by itself. And then the next step is you break this up, 2x minus 1 equals 5, or 2x minus 1 equals negative 5. You do both of these, okay? Technically, that's not really what happens. If you want to get technical on it, okay, this is what happens. Okay, they told you that absolute value of u equal d means u equals plus or minus d, and that's correct, but the reason that happens, remember we talked about this, is that absolute value of u is either u or it's minus u. Okay, so that's what happens here. I am fine with you jumping ahead to this. The only reason that I even show this step is because when we get to inequalities, you're going to want to see that. That's going to make more sense to you. Okay, so anyway, regardless, add 1 to both sides, get 2x equals 6, divide both sides by 2, and you get x equals 3 as your first problem solution. You also have add 1 to both sides and get 2x equals negative 4, divide by 2, and get x equals negative 2. And so once again, we have two answers, 3 and negative 2. You are certainly welcome to go back and check your answer here, plug in and do it. Make sure you do the absolute value last, but you don't have to. This is but only the radical equation is the one where you have to show me that you're checking your answer. You absolutely have to. Okay, so the steps again: isolate your radical first, isolate your absolute value first. Right? It's the same basic steps. The only difference is now instead of squaring both sides, you break it apart. You say absolute value is equal to itself, or it's equal to the opposite of itself, or you can write it like this. Right? So either one of these is fine as a way of handling this right now. So again, hit pause. Well, don't hit pause quite yet. Here's a second problem for you. Hit pause, give this one a shot, and then you can check your answer afterwards. Okay, so give it a try and then come back. Okay, so what we're going to do is we're going to hit add 17 to both sides because we have to isolate this first, right? Absolute value equals 21, and now you break it into two pieces. 4 minus 5x equals 21, or what? Negative 4 minus 5x equals 21, which is the same thing as 4 minus 5x equals negative 21. All right. So we solve this, subtract 4 from both sides. Don't forget your signs. Negative 5x equals 17, divide by negative 5. You get x equals negative 17 fifths. That's okay because remember the x is inside the absolute value. So if you were to check yourself, it would be okay. All right, here we're going to subtract 4 from both sides and get negative 5x equals negative 25. And then if we divide both sides by negative 5, right, you'll get x equals positive 5. Negative 25 divided by negative 5 is positive 5. And you get these two answers. All right, and if you check them, they do work. And so those are your two solutions for that one. Okay, so radical equations, absolute value equations, they have some similar processes where you have to isolate the radical or isolate the absolute value first, and then you either square both sides for radicals or you break it apart into two pieces for absolute values. All right, and again, once you do this, once you break it apart, everything from here down, that's old stuff. So make sure if you are making mistakes from here below, then you need to go back and take a look at section 1.3 for solving linear equations or section 1.5 for solving quadratics, okay? And brush up on that stuff. It hasn't been that long, but just in case, okay? So I hope that helps, and we will see you around.